Okay, so today we're going to look at the equation of a circle. As you will see on page 19 of your log tables, there's not as many formulas as you would have had for the line, two realistically, both in relation to our first topic, the equation of a circle. But what you will need is, as you'll see in this video, a lot of uses from the coordinate geometry of the line where we apply them to circle questions. So we're going to start by looking at the equation of a circle. The two formulas you would have had in your log tables is x minus h to be squared plus y minus k to be squared equals r squared, and the second one is x squared plus y squared equals 2gx plus 2fy plus c equals 0. So what's the difference, and when do we what do we need to find when we apply certain particular equations? The first one is if we need to find the equation of a circle, we use the first formula. And then the second one is if they've given you the equation of a circle and you need to find either the radius or the center, that is when you would use the second of the two formulas, where it tells you explicitly that the center is minus g minus f and the radius is the square root of g squared plus f squared minus c. So that's the first part that we're going to look at with circles. The second idea with circles, I'll move this over a bit and hopefully it doesn't fall, which it didn't. So I'm going to move it a bit more. Boom. Okay, so now I'm going to move it a bit more. Okay, so the second one we're looking at is tangents. A few ideas that we need to know is that the slope of a tangent, okay, for drawing a tangent, that from the center to the point of contact, the slopes are perpendicular. Okay, so it means that the tangent and the line from the center to the point of contact, they intersect at 90 degrees. Okay, so if we had a tangent to a point not in a circle, should I say not? We would have, like the diagram shows, we'll have a point here and we'll have a circle where there's two tangents. What you would use here is you would use a perpendicular distance formula. You'll be given the point, but you won't know the slope. So, and you will find two values for m. Okay, two values for m. And one last thing, remember that a tangent, it makes right angled. So if I did have a question where there's a tangent, there's a center, okay, and you're asked to find the distance in relation to a tangent, you could be using Pythagoras' theorem. So just remember that with a tangent, if you're looking for a distance, they might have given you the radius, they might have given you 2 points. You might use a distance form to find the 2 points. To find the third one, you would use Pythagoras' theorem. So that's the second step we're going to look at. The third step, there you go, so is going to be in relation to lines and circles. The first thing you have is the point of intersection. So if you had a line and a circle, you need to find the point of intersection. What you would use is simultaneous equations. One linear, which is your line, and one non-linear, which will be your circle. And you would find two values for x, two values for y. That just remember to make one variable the subject and to sub it into your nonlinear equation. If you are asked to intersect an axis, be it the x-axis or the y-axis, if it was the x-axis, you let y equals 0 and you'd solve it as a simple quadratic. So intersection of axes, if it was the x-axis, y value equals 0, and solve quadratic for x. Okay. And then the last one we're going to look at in lines and circles, okay, would be if I had two circles and we had to find a common chord. So if you had two equations of lines where you would pretty much, two circles, you take the two away and you would eliminate the x squared plus and the y squared to get a line chord in the form ax plus by plus c equals 0. Okay, and the last section in circles we're going to look at in this video is where we have two touching circles. So how we know that two circles touch externally is if the radius of the first circle and the radius of the second circle, R1 plus R2, is the distance of the two centers. How we know the two circles, that would look like, okay, where they touch externally, where they touch internally, you've got a big circle and you've got a small one. So the radius of the big circle minus the radius of the second smaller circle would be the distance between the two centers. Okay, so we're hitting about 7.5 minutes for this video. I'm going to stop it here now. I'm going to do a second video to finish off one or two more sections on the circle. Okay.